Okay, so today we're going to start with a demo of exercise 214 and kind of work through basic shapes. And I think the fundamental concept here is that we're now going, we've worked on small shapes and built up kit parts and little pieces. And then we went into the topography. It was kind of an unwieldy surface, and we sliced it up. And now we're getting into pure form. You know, I want to build this skyscraper, and I want it to look this way, or whatever. And then we'll divide it up and put the floors in and all the rest of it. But we're going to start with the form. And so as part of today's exercise, you really want to explore form. You want to play around with this is like free reign. You can do anything you want in terms of creating a twisting, goofy building. Even if it's not the most buildable thing. It also helps if you do lots of iterations today, because you will find that the first one that you do might not turn out the way you want, and you need lots of iterations to pick from. But we're going to use these buildings as we go through over the next 2 weeks or so, working through learning a lot about V-Ray renderings and environments and reflections and that sort of thing. So today is about form, and we'll get to that. You did get your assignment 203 handout, which is kind of where we're going with this. It is due on the 30th of October, so the day before Halloween it's due. So today's October 2nd. There's obviously a long time here. You, as is the case with most of the assignments that I give you, you don't have the skills to do this assignment just yet, so don't panic just yet, but I like you to be thinking about it. This building that you're doing for your assignment is bigger than the building we're doing for our exercises. So it's a taller building. So it's important to recognize they are in fact two separate things. So you need to create two different buildings for that. But hopefully you'll learn a lot from your smaller building, which is what we're working on in the exercises. So you'll also notice that there is a part 4 listed on assignment 203, which has to do with 3D printing your skyscraper. I have no idea how that's going to turn out. Okay? I've said from the beginning that you're the experimental class. It may work, it may not. If it's not working, I'm not going to penalize all of you because it doesn't work. Okay? So the up through part 3, you'll definitely be graded on, and that's consistent year after year. Part 4 is the part that I'm adding this semester that you guys are going to experiment with. We are supposed to have somebody come in and train us on 3D printing. I have yet to hear when that's going to be or if it's going to be, in which case I'll have to do some training on it. So we'll kind of sort that out as it goes forward. But it is definitely something that I think is important and that I want you guys to have as a skill to be able to go do it. But the logistics are the iffy part. It may also be the kind of thing where we do assignment 203, you turn in everything up through part 3, and then we do the 3D print, and it's due sometime before the end of the semester. I don't know yet. We'll see. Okay? So be flexible with me on this, because I don't know the full details of it. As much as I like to have things ironed out, and this is how it's going to go, it is not going to work that way, no matter how much I want it to. So we'll get into this a lot more, but really a lot of assignment 203 is about representing your building, rendering it well, having reflections, having environment, having context, skies with clouds and real suns and time of day and all that kind of stuff. So we're going to get into that, and your renderings are going to improve dramatically going forward because we're finally going to have good stuff as a background to render against. So anyway, we're going to start today with exercise 214. I'm going to demo through kind of the process of building these buildings and playing around with them and modifying them. And then after I'm done lecturing, I'm going to turn you guys loose rather on your own today because I'm going to go prep I have to go buy the cardboard, and then I'll prep my pieces, and then I'm going to laser cut the topo that I did last class, and I'll put it together in front of you, assuming somebody in this room has glue. It's the only piece that I need. But assuming that somebody has glue, I'll put it in front of you. For anybody who has never laser cut before, if you guys want to come over while I do the laser cutting over there, just to kind of get a refresher or whatever, or if anybody wants just a refresher because they haven't done it long enough, you're more than welcome to come over while I actually do the cutting. But you guys will make appointments with the lab technicians to decide when you're going to cut and your appointment window and that sort of thing. If you have your AutoCAD file ready the same way that it was supposed to be last class, it shouldn't be a problem. You should be able to walk over and cut it. Other than, of course, you have to have the material too. So it should go really easily and really smoothly, but sometimes there are issues. So anyway, I am going to do that during the lab portion today, which means I won't be around to answer lots of questions during the lab portion. So you guys are a little bit on your own today. That being said, of course, if I'm here, I'll help you. I'm not saying I won't help you. There's some logistical challenges. So we're going to start today by working through kind of building a skyscraper and working in this pure form state. And I want to kind of walk through some key ideas for how this comes to being and how you're going to create this building. So we can start with a basic, rectangular skyscraper. We could do a box corner to corner, for example. I'll do box corner to corner in this example. I'm going to start at 0, 0. And our size here is going to be at 100 feet, 200 feet as our base, 100 feet by 200 feet there. And our height is going to be 600 feet, right? 600 feet, yep. And let me zoom selected, and that gives us a general sense for the size that we're going for. So this is its most basic form as a skyscraper. It also happens to be a rather boring form as a skyscraper. Now we could take this a step further and start to draw a fancier floor plate and extrude that floor plate. So for example, instead of doing this rectangle, I could say at 100 feet, 200 feet, and then I could divide this up, say maybe go over by 50 feet, 25 feet. Oh, come on. And we'll go in by 50 feet there. Come over like that. We do a few mirrors here. There we go. Let me do some trims. These are all the same commands you're used to that you've worked with before. All right, so I've got that shape this time. I'll join it, and then I'll extrude the curve. Extrude curve. Remember, we do want it to be solid, so solid should set to yes, and we'll make the height the same at 600 feet. Okay, so I made the building a little bit more complicated just by doing an extrusion. Now, maybe we want to make it a little bit more complicated than that. Instead of having the cross shape, maybe we want to have some diagonal sides or something like that. But maybe I want it to kind of change a little bit as it goes up. So in the first option, I could start with, let's say, we'll do 200 feet here. We'll do 50 feet. This is going to be at 50 feet, negative 150 feet. We'll do another 50 feet there. And I'll close it. Maybe it's something like that. If I took this shape, though, and I copied it, V for vertical, and I went up, say, halfway, so that would be 300 feet or so, and then I could go all the way up to 600 feet, the third piece. I could then modify this piece in the corner. So maybe, let me turn my points on for this. Let me move that corner. We'll go 50 feet. Now let's go a little more than that. Like that. So we're coming up to that place, and then we're going back to wide again, for example. I'm making this up. It doesn't matter. This is an expression of form. And I could take the first two there to there, and I could say loft, like that. And I could take the next two, say from there to there, and I could say loft, like that. So now I've increased the complexity of that. I have this little kink that's twisting the side of this. So in this case, because I'm doing lofts, all of these surfaces are what is called developable surfaces, which means that you can create them out of a flat sheet. It's just a matter of twisting the sheet to create the end result. It's not a bulging surface. It's not an orange. If I had an orange and I wanted to lay it flat, I would have to break apart the peel of the orange to lay that peel flat. It's like a globe. You guys have all seen those maps, and you either look at Canada and it looks gigantic because it's stretched, or it has a bunch of slices through it because you have to be able to fit it back together. We're trying to keep our shapes roughly like this, where they're ruled or flat between 2 points. So something like that is doable. Okay, if I wanted something curving, I could certainly establish something like that. Let me go back to my, we'll say at 100 feet, 200 feet. And let me take some circles here. Let's do a radius of 50 feet. And let's do a radius of 100 feet. Something like that. That would be a really awkward building. Let's move this over by 50 feet. Something like that. Again, trim. And we could trim that part off. And we could trim that part off. Let me join this together. And let me go ahead and move or copy V for vertical. And we'll go up 300 feet and then 600 feet. Now you could, of course, I'm doing it in 300. You could do it every 100 and it could change every 100 feet. You could do it at 150, whatever divisions work. Let's take this particular piece and I'm going to rotate this one around the center. So let me create a temporary line there. And I'll take this piece, rotate. It's a regular rotate, not a 3D. And we're going to flip it so that it's like that. And then I could take the first two here, and I could loft. Make sure that these 2 points line up correctly, which they do. And then I could take this and that, and again, I could loft it there as well. So in this case, similar in shape, but this time it has a curving profile instead of a straight profile. So just another strategy, something else that we can create. This one's going to be hard because it's not going to develop the same way that something like this was. We're not going to be able to unroll it. So long term, as part of your assignment, I'm going to ask you to unroll it. So this is less than ideal for the long term. But in terms of today and exploring what you're doing, by all means. So sometimes you want to take a shape and change its complexity where it started from and then maybe make it twist. So let me take this shape again. And I want to transform this so that it twists. So I could, of course, have a top and a bottom, and I could rotate the top versus the bottom or something like that. But I can also use something called a cage edit. And a cage edit will transform this using a set of control points. So if I go up to transform and I choose cage edit, or excuse me, cage editing and then cage edit, you can skip create cage. It just separates it out into 2 separate commands. It's easier to just do cage edit. It's going to ask me to select a control object, or I can pick bounding box. I just want a bounding box. It's easy. Coordinate system, yeah, world is fine. And then we get to something called cage points. So in this example, we have 4, 4, and 4. I'm going to change these at first to be just 2 on each of these. So we'll say 2 for x, 2 for y, and 2 for z. This is simplifying. Notice also that the degree of the curves have changed from 3 to 1. And it'll make sense as we go forward. So I'll go ahead and leave that at 2, 2, and 2, and I'll hit enter. Region to edit global. There we go. And so now my object, if we look down at my object, has kind of a bounding box around it with these little control points on it. If I were to select those control points there and, for example, rotate, let me snap to the center of this object here, if I can. It's not going to let me. Sometimes you need a little extra. I just need to know where the center is. If I rotate from the center, maybe 15 degrees, it's going to twist my building by that 15 degrees. Now, because I did it in its 1 degree of curve, the lines are going to stay straight. So the point from here to there is going to stay straight. It's going to be a straight line. It's not going to curve at all. So let me go ahead and do this again. So I'm using the same shape here so that you guys can see this in contrast to each other. I'm going to go in and do the cage edit again, which would go to transform, cage editing, and then cage edit. bounding box, world. Okay, then we're going to change this to be different. So I'm going to leave my x and y point counts at 2, but I'm going to change my z point count to 3. And I'll again leave everything at 1. I'll go ahead and hit enter. Default global is fine. There we go. So now in the z direction, I have 3 points, 1, 2, and 3. So once again, I could create a temporary little line here to give myself a guide. And I could then select these lower 4, and we'll rotate. We'll say 15 degrees that time. And so now I have a kink that's happening in the building, but because my degree of curvature is still 1, it's a straight line from here to there, and another straight line from here to there. You guys see how that works? So let's change it on the next one, same concept here, and we'll do it with a degree of 2. Bring that over, cage edit, bounding box, world. Okay, same z point count as 3, but our z degree is going to be 2. There we go. I'll go ahead and hit enter, global, perfect. So same thing. I need my little cheater, again, to know where that center is. Let me take these 4, and I'm going to rotate, exactly the same as last time, by 15 degrees. So when I do it this time, because my degree of curvature was set to 2, instead of having a straight line from there to there and a straight line from there to there, I have a curving line that goes all the way through back up to the top. So it's a very different look for what I'm doing. I could change my degree to be 3, which gives us even more flexibility in the curve. Whenever you do that, though, you're very unlikely to be able to unroll the surface later on. So I'd stick to 2 if you can. It doesn't mean that every two-dimensional change is going to be developable or unrollable, but it's more likely to be. I can also manipulate my building by, for example, taking these 2 points and just moving them. So I could say move, and I can make the top of the building a little bit bigger. I can make these 2 points, and I can move them the opposite way. So you see how I can create a lot of different shapes. Now, is this really a feasible skyscraper design? Probably not, but you know, whatever. You get the idea. So as I'm going through and transforming these objects, I'm starting to play around with them. Now, if I take the same object, and we come over here, and I do a cage edit, again on it, bounding box, world. Okay, I'm going to change these all up to 3. So x is 3, y is 3, z is 3. My degrees are going to be 2, and 2, and 2. I'll hit enter. You'll see that I end up with more control points. So on those last set with x and y set to just 2, I had just a single control point on each side. If I go to 3, I have control points in the center. And so you can see I can add to the complexity. So for example, I could take this point and I can move this point out and cause the side of the building to bulge. This obviously is curving in 2 directions. It's curving this way and that way, which means I couldn't roll it flat. It's starting to be a spherical curving object. So something like this in practice, if we were actually to go out and build a skyscraper, this would be really hard just to construct it. Right? We could do it with facets, but it's never going to be a smooth surface. There's no real way unless it was some kind of custom setup. We can't 3D print a skyscraper, so we can't do it. In terms of 3D printing, there's nothing wrong with this. We could 3D print it, no problem. But that's a small scale object, not a big scale object. Okay, so what I want you to do today is I want you to play around with this cage edit and figure out what these various buildings might look like. You see that I really quickly went through and created lots of them. Do the same thing. Create lots of different ideas. I've seen lots of different ideas. Play around with it. Have some fun with it. It should be fun for you to work through it. Once you've gotten to the point where you have a building that you kind of like, okay, so let's say that I like this building. This is the building that I like. Go ahead and take that out from the stack, maybe put it on a different layer so that you can turn it off, and then we're going to work with that particular building. So I'm going to change and make layer 2 called Skyscraper. And I'm going to turn off the default layer. Whoops. Let me take this object, put it on the skyscraper layer, and we'll turn off the rest. There we go. So I'm just working with this particular object. I'm going to make a sublayer here called floors, or floor. And I'm going to start to build out the floor and the ceilings for all the various floors that are inside of this. So I probably need another layer, ceiling. No, I always get, sorry, had to try to spell it right. We'll put ceiling in there, floor and ceiling. We'll start with those. And to create this, I'm going to go ahead and do just a rectangular plane that's a little bit larger than my building. It might be easier to do this in the top view. There it is. Make sure that's a little bit larger than my building there. Yeah, about like that works. Let me move this over a little bit, like that. Perfect. Larger than my building. And it's currently down on the ground plane. So if I was doing the first floor, it would be there. I would then copy this. This would be vertical. And my next floor, the 24-foot lobby or ground level, we're going to go up 24 feet. So I'll go ahead and type in 24 feet. There we go. There's my next level. I'll then take, these should be on the floor layer, by the way. Let me change object layer. Let's make that one current. There we go. Then from here on out, it's going to be 16 feet on each floor. So I'm going to copy this. It's again going to be V for vertical. And the next one I could do at 16 feet, for example. Now the next one would be 32 feet, and I could keep doing the math. But to me, that's a little bit too hard. Instead, I would rather come back to where I had this first one, and I'm going to do an array, which means I'm going to copy this multiple times over the course. And we did this with the glass wall. Same concept here. So I'll do array. I'll type array. Number in the x direction is going to be 1. Number in the y direction is going to be 1. Number in the z direction is probably going to be like 30-something. OK? Might be more. I'll hit enter. Z spacing or first reference point. So we know it's going to be 16 feet. So I'll start from there. We need to go up 16 feet. There we go. I'll click. And we'll take a look. Oh, I didn't have enough floors. So I need to go a few more. Let's go 36. And that gets me there, 36 floors. Okay, so those are all the floors of each of these buildings. So I'm going to commit to it to accept. And there they all are. Now I need to do the ceilings. Well, the ceilings, there's going to be, in a skyscraper in this kind of a building, there's always space between the floors where you put all the mechanical stuff, the ducts and the whatever. So we're going to do it generically, maybe about 4 feet or so. So I have several options for creating this. I could take this first one, copy it. This is going to be V for vertical, and we'll go up maybe 12 feet. Something like that. Whoops. There we go. So there we can see it. Once I have that copied in its correct location, then I can do my array again. So I'll do array, number in the x 1, y 1, z 36, z spacing. This is going to still be 16 feet. I just moved it up 12 feet, and then it's going to be every 16 feet. So we'll do 16 feet, and I'll hit enter. Like that, and that would then create this whole next set of objects. Now, before I did that, though, I should have changed my layer, because now I'm going to have to go through and select all of those individually. So let me change it first. Change object layer, array, 1, 1, 36, 16 feet. And there we go. I'll accept it, and I have those particular pieces. So now I need to go through and I need to trim off some of this. Oh, and I need a little bit of space in the lobby. So let me take this one, and I'll just copy it down. There. So now I need to trim the excess. So I'll use my original object here as a trim. I'll type trim, and then it's best to do this in small groups. So we'll work through. It is entirely possible, especially if you use a lot of cage editing, that there'll be a point on your building where it just won't trim. And it's probably because one of the seams has opened up. And that, again, is a sign that you wouldn't be able to 3D print the object either. But we'll get to how you fix that along the way. But if you have a reasonably well-done shape, you should be able to trim through all of these floors. All right, so I've made my way through all of those. And I should probably make another sublayer and call that the skin of the building. And so let's put that, and let's take my building and place it on the skin. And so that it's a little bit clearer, let's change the skin to be blue. And we could change the floor and ceilings to be different colors. But there are all those floors and ceilings. So I took the shape, the geometry of the outside, and then I placed in all the floors and I trimmed them. So instead of building it up floor by floor, I've created the overall shape, the form of the building, and I'm then slicing it up into its individual floor plates. I'm going to leave these transparent, though I could fill them in if I wanted to. If I were to fill these in between the two floors, I'd get conflicts when I went to render. And so there's another way of kind of compensating for this long term, and I'll show you guys how to do that as part of the rendering process. So now that I have these, I do need like an elevator core or something that punches all the way through the building, so let's do that. I'll create another layer, and we'll call this core. I'll make that the active layer, and I need, I don't know, maybe about 30 by 30. And we'll bring this all the way up to the top, something like that. And then this needs to go all the way inside my building. So we'll look down on it, and we'll place it somewhere inside the building. And for the purposes of this class, I'm not getting overly precise about the mechanics of making a skyscraper work and how big your core is versus the floor area and the structural dynamics and whatever. That's what 221's for. You guys will go through that, and you'll talk about that as part of your process. This is about form making more than anything else, but we do need to be able to get up and down, so making an elevator core is not a bad idea. So now that I have that established, I'm going to take that extrusion and explode it so that it's broken apart, and deselect the top and the very bottom of this. Let me reselect that one side that I missed. There we go. Control deselect. There we go. I'll join that back together, and then I'm going to use that as a trim. And so I can do this in the top view, or I can set up my perspective view, which I always think is kind of entertaining, to look straight down through the core. And I'll type trim, and then I'm going to start clicking. And as I work my way down, oh, you know what? Let me get rid of this top so you guys can see it happen. Okay? Let me trim with this surface. Come on. Right there. Trim. And we'll take the elevator down. There we go. I think we made it to the bottom. So now I have that piece that goes all the way through. I have the core that goes all the way through the building. So once you have your design set up, this is kind of what I'm after. Go ahead and assign materials to these various layers and get kind of a basic rendering out today. Next class, we're going to take this same thing and we're going to start working at it in context with environments and how do we make the materials really look right and that sort of thing. So make sure you save this as part of today. But today's about the form and the geometry, and then we'll get into the rendering next class. Are there any questions before I turn you loose? Let me make sure I have covered everything. Oh, by the way, in part 2, I have the floors at 10 feet, and there's 50 floors. I modified that. They're 16-foot floors, so there's only 36 floors. So just ignore that part. I should have updated it. Question?
Just a quick question. How would you just submit this one?
So do a rendering of it. Put some materials on it. It's not going to look perfect, but we're going to go with it. Okay. Yeah, everything should be on, and you'll do a rendering of it. You'll probably need to change your environment background to be white. So here, that should go to white before you do the rendering, and then apply. You can go ahead and load the skyscraper glass as a material. It won't look that good today, but it'll look better when we start working with it. Let me just double check that I made it through everything. Right? Okay, here's one other important thing to note. Part 8, or step 8 down at the very bottom. This is the first time on an exercise that you're going to start commenting. So thus far, we've only had 4 comments in the semester. You guys have forgotten all about it. You shouldn't have just yet. Okay? So you're going to start commenting. Okay? And I'll make a note and I'll keep reminding you. So you don't really have to do anything today, but when you come into class on Wednesday, you should sit down and write your comments. Okay?